Alright, it's time to write some code. I'll start out with the bare minimum, work my way up. But we're also going to need a library for this one. Okay. So let's go searching on the internet for that. IR Arduino library. Now you can get this at different locations, but for me, you know, I kind of aim for the Arduino CC. I like that one. Ken Sheriff is the originator from the Arduino library, but hey, his library rocks, and I hope I'm pronouncing his name right, but Sheriff. Now, to find his library. There it is, IR remote. Good. I'll save that. I'm just going to save that to my hard drive somewhere, and I'll show you where to put it. Right click and open container folder. Double click that to get it open. Now this is a library, so it goes here. Check this out. For me, it goes to C drive, program files 86. I'm using the Arduino 1.51 R2 because I have the newest Arduino, and what happens is I'll have to have that library or that program to use it. Right now I'm just using an Uno, but I also have a different one, so I had to upgrade. If you look in here, you have libraries, and all I did is click and drag this to here to use it as a library is concerned. Libraries are just a separate extension of things where we can call upon them from time to time by including them into ours. That way we don't have to write huge programs. We could just say, hey, go look at this real quick, reference it, and come back with the calculations. So libraries, very important. Some libraries only run in certain versions of like Arduino. So I've had some libraries run only in 223. This one does run in both, 1 and 223. Okay, now that we have that in place, I can call upon it. And to call upon it, we say include. Include then the less than IR remote period H. Now in the last chapter we learned how to pulse something. Okay, we actually had the frequency, we dialed it up, dialed it down. I showed you the difference between Arduinos, and you can go further with one and not so fast with the other. But this library allows you to do that without writing huge lines of code to pulse something at a certain frequency. Okay, that's the advantage. So let's define some pins. Let's define pin underscore IR to be 3. So that's my pulse width modulation pin. Let's also define pin underscore detect. That would be 2. And then also define pin status to be 13. Perfect. And I'll just do this. This is my LED. It's my receiver. And this is my out LED or status. Perfect. Sometimes it helps to comment out or comment things, because later on you stumble upon this to Frankenstein it with something else, and you're going to need those comments in place. There's no doubt about it. All right, we're stating IR send. This is part of that library, and we'll go into void setup. Open bracket. Now we have to define our pin outs and pin ins. So pin mode, and again, I don't like to type very much, so I'm just going to snarf that and input. And I don't know if this is going to help, but I'm just going to do this, paste it, Control C, copy that one, paste it here, and change this to output. There we go. I don't know if that was worth it, but there we go. IR send, and this is the cool part. This is really cool. Enable IR out to be 38. What is that? That's 38 kilohertz. Isn't that sweet, right? So I could state the different kilohertz. And if you use that to your power and your benefit, so you think about the frequency that we wrote last time, how we had to use the potentiometer to change that frequency. Well, there we go. We can write whatever frequency we want in there. It's pretty sweet. So if you have the different receiver, the 56 kilohertz one, we could write 56 in there, and it'd be all right. So if it doesn't work right off the bat, you should just definitely check what kilohertz that your receiver is receiving at, and then write it there. So IR send, period, mark, and 0. So you'll find examples of this type of code on that blog too. That's where I'm getting some of these inputs and outputs and the different IR out. That's another thing I'm kind of stealing away from you as a student, because you know I know what to steal and what not to steal. I'm just showing you what it is, but at some point you're going to have to learn how to Frankenstein, I call it, code. You know, steal little bits of here and little bits of there, put them together, and come up with something new. Something like what hipsters do, I guess. I don't know. So are all hipsters like code writers? Weird. Never thought of that. So void loop, open close brackets. Okay. And this is the cool part again. On digital write, pin status, again stealing this, and I'm putting a little exclamation point here and say digital read. And what does that do? Well, if it's hot, if it's positive, it'll write it positive. It's negative, it writes it negative. It just reads the digital read. It's very cool. And then it'll put it on the pin status. So this one, whatever it changes to a positive, this will change to a positive. If it changes to a negative, this will change to a negative. Off and on, tit for tat. Very cool, right? Why? Because I didn't have to write an if statement. If pin is positive, do this. I didn't have to do that. And last but not least, close bracket. So that's a very small code. So powerful. Okay, let's see if I got my serial port, got my board Arduino. Yep. And let's compile that. Throw it out there. And you should also save this. This is a very good one to use later on. So I'm going to be calling this something. I'll call it IR sensor. Okay, let's see if we broke this. Alright, over on our Arduino side, I have this. Getting my hand close to it. Oh, yeah, look at that. Backing it away. Let's take the zoomer cam. Zoom out a couple notches. Take my file. Okay, sneaking up on it. Sneak. So you can see I have to get really freaking close with the file being that way. But if I go this way, sneak. I have to get pretty close. Right here. That's where you aim this thing. And, you know, once it's on the actual robot, that's where I usually aim. For right now, this is just breadboard and doesn't really matter. Good. But as far as big objects are concerned, bam, instant gratification. About 4 inches away. So there is your infrared sensor, code, hardware, the whole dealio. And now that we have this, I would say this is the end project, and we're going to look at a different thing in the next chapter. Enjoy.